Hello everybody! Today we talk about a periodic motion, so-called oscillations. There is a simple physical model that helps us to consider all the main types of periodic motion. It's called a spring pendulum or an elastic pendulum. This system consists of a spring connected to a pivot suspending a mass. The stiffness of the spring is considered a constant that is quite close to reality when the amplitude of the oscillations is relatively small. In this case, the spring has a linear reaction force when extended or compressed. The problem of the dynamics of the spring pendulum can be solved using a combination of Newton's second law and Hooke's law. This is the simple simulator based on this approach. In this window, you can set the basic parameters of the system. A stiffness of the spring, we set the stiffness of 10 newtons per meter. This is a quite weak spring. And a mass, let's say 150 grams, for example. And now we can simulate the elastic pendulum that oscillates horizontally. Let's start with the simple harmonic oscillations. These kind of oscillations occur when the spring pendulum moves without friction. Check it out. As you can see, the graph of position as a function of time is graph of a cosine. That's why these oscillations are called the harmonic oscillations. Well, what will happen if we add the friction into a system? If the friction is not large, the oscillations remain periodic, but its amplitude gradually decreases. It's called a damping. You can ask me, what if the friction is large? For example, the pendulum oscillates in oil. Why not? Well, the system becomes over-damped in this case. All the energy dissipates very fast, so the motion becomes aperiodic. Watch this. And finally, what if we add an external oscillating force into a system? Well, if the frequency of this force is slightly different from that of the spring pendulum harmonic oscillations, then we get the following kind of motion. Look at this. We see that the amplitude of the oscillations also oscillates, and we have an envelope of the amplitude oscillations here. Do you recognize this kind of a function? That's a sine function, right? Okay, but what if the frequency of the external force is exactly the same as that of the pendulum oscillations? Watch this. As you can see, the amplitude increases, potentially to the infinitely large value. But the pendulum oscillates with friction in this case, so we get the beautifully steady harmonic oscillations here. That's it. That's how this simulator works. Thank you for watching.